Hi everyone, as I promised, first year calculus, more derivatives and integration. So let's find the second derivative of y equals 1 over x. So to find the second derivative, of course, you have to do the first derivative first. So y prime equals, and you know what I'm going to do here? I'm going to change this to y equals x to the negative 1. So if y equals x to the negative 1, then y prime will bring the exponent down and take away 1 from the exponent. That would give me negative 2. And so the first derivative will be negative 1 over x squared. Now to do the second derivative, we definitely need to work from here rather than here. So again, we'll bring the exponent down. Negative 2 times negative 1 is positive 2. X take away 1 to the negative 3, and therefore y double prime, and that's y double prime right there. I'm just going to correct this right here. Y double prime, second derivative. So this will end up being 2 over x cubed. So here's another question. If d is the distance given by d of t equals t cubed plus t squared plus 2t, find the acceleration. So just for all of you, if we have distance, we take the derivative, we get velocity, and then we take the derivative and we get acceleration. Okay, so basically just do the derivative. And then you do the derivative again. So the second derivative gives you acceleration. So if we do d prime of t, we will get 3t squared plus 2t plus 2. So that's basically what the first derivative is. Now, after that, we're going to do d double prime. So the second derivative to find the acceleration. And maybe, you know, what we'll do, we'll just, here we call it velocity equals, and here is the acceleration equals double prime of t, which equals 6t plus 2. And the derivative of 2 is 0. So this is my answer for the acceleration for this question right here. So here's another question. Find this here, another notation for the second derivative. So y double prime or this. Easier to write y double prime, isn't it? So what we'll do here, finding the second derivative basically for this equation right here. And to do that, we have to find the first derivative first. So y prime, so it's going to stick to y prime equals, you bring the exponent down, you get 10, and you write the same thing inside the brackets without any changing. And you take away 1 from the 10, that's 9. Now, the chain rule tells you after you do that, you go inside the brackets right here and take the derivative of that as well. So you have 2x minus 12. And that's what's inside the bracket. So that's the chain rule. Now, the second derivative is going to be product rule. So product rule is y equals, if y equals a, b, yeah, then y prime would be a prime b plus b prime a. And what I'm going to do to this, as a matter of fact, let me just get rid of this right here. Write it closer. So as we said, here is 2x minus 12. To make this easier, I'm just going to distribute the 10 into here and into there to make it look like a and b. So when I distribute that into there, I'm going to get 20x minus 120. And then we have the x squared minus 12x to the power of 9. So this is being A and this is being B, just so that, because there's going to be a lot of stuff written in there. So what I'm going to do, I'm just going to find A prime already. A prime is just 20 because the derivative of 120 is just 0 and the derivative of 20x is 20. But the B prime will be 9. Keep what's inside the brackets the same, times to the power of 8, take away 1, and then this will be multiplied by the derivative of what's inside the brackets, which we already did right there. So, and that's B prime. So now we could just y double prime, we're just gonna fill in stuff. So A prime, which is 20, times B, which is x squared, what is that, minus 12x to the power of 9, plus, and then the derivative of, or B prime, or the derivative of B is given right here. So I'm just going to write that maybe as 9 2x minus 12 x squared minus 12x to the power of 8 times A, which is 20x minus 120, close the bracket. Now at this stage, what I'm going to do, I'm going to take out stuff that's greatest common factor. Okay, so y double prime I'm going to take out the this here, because we have this in both terms, because we have one term, two terms. So we're going to take x squared minus 12x to the power of 8 as the greatest common factor. To the power of 8. And then what I have inside the other brackets is 20, and I will have x squared minus 12x here, because when you take this and divide this by this, you get that, plus 9 2x minus 12 times 20x minus 120. If you want to simplify the furthest, you have to do a little bit more. And I'll tell you what you have to do. So I'm just going to rewrite this, x squared minus 12x to the power of 8. Now here we have the 20 right here, x squared minus 12x. Here what I'm going to do, I'm going to pull out a 20 from here and a 2 from there. So if I want you to, if you want me to make this simple for you, this here will look like 2x minus 6. And this part right here will look as 20x minus 6. Okay. So, wow. So therefore, now we have 2 and 20 times 9. So basically, 2 times 20 is 40. 9 times 40 is 360. So plus 360 x minus 6 squared, because it's both of them here. So I just wrote a square instead of that. And therefore, now we know we could pull out a 20 from here because it goes into both of them. So I'm going to pull out the 20 and put it right in the front right here. X squared minus 12x to the 8 brackets x squared minus 12x, because the 20 is gone, and if we take away 20 from here, that's going to give me plus 18x minus 6 squared. 8 times 20, No, hold on a second. 8 times 2 is 16. What am I doing? Sorry, that's 18, not 20. Yeah, 18. Because 18 times 20 will be 360. You could FOIL this if you want and collect like terms and distribute the 18n and do all of that. But you know what? We'll just leave it here. And this is it for this question. So here's another question. They're giving you this. They say find y double prime. Again, have an x squared on the bottom. It's better to bring it to the top and make the exponent negative. Otherwise, you're going to have to do the quotient rule, and it's the derivative of 1 is 0 and all of that stuff. But this, what we advise students to do here, first thing, change this into x to the negative 2 plus 2x to the negative 3. Now, y prime will be negative 2x to the negative 3 plus or minus, because negative 3 times 2 is negative 6x to the negative 4. And the answer for this will be negative 2 over x cubed minus 6 over y to the 4. Always want to have the final answer as positive exponents. But when I'm doing y double prime, I shouldn't be looking at this. I should look right in there. So y double prime will be 6x to the negative 4. You know, you're minusing 1. Lots of people here, sometimes they add 1 instead. And then you bring the negative 4, there will be plus 24 x to the negative 5. And therefore, my final answer is 6 over x to the 4 plus 24 x to the 5. Okay, we will do one more. So here's a question. They want you to find y double prime. So now I'll tell you two things here. You could make your life really hard with this one and go for the quotient rule. The quotient rule, if y equals a over b, then y prime would be a prime b plus b prime, sorry, minus b prime a over b squared. So if you do that for this one, you made your life really tough. This here simplified first, okay? So if I want to do this, definitely I want to simplify, because when we have a fraction like this, it means x cubed. Like if I want to just break it down for you, so x cubed over x plus x over x, which gives me x squared plus 1. Now y prime would be 2x, and y double prime would be 2. So could you imagine if you use this? You will get to this answer if you don't make any mistakes on your calculations, but you'll spend a good 6-7 minutes to do it that way. And that's time that you need on your final exam or on a test, where because in math, always simplify and then go to the next step. Lots of students forget to simplify and they want to go to that step right away. So in math, always simplify and then go to the next step. And that shows you how easy this is. And this is it. That's all I'm going to do for second derivative. Thank you for watching again. Hit that like button. Please subscribe to my channel. Share with others so they could benefit. Thank you for watching again. Till next time. Bye-bye.